guys, I am ready to do lesson 2 of module 16. I'm on page 425 in your math workbook, so make sure you have that and a pencil. This lesson is called Represent Equivalent Fractions with Larger Parts. So this is going to be very similar to the lesson that we did yesterday where we did equivalent fractions with smaller parts. So we're just going back and forth between making this parts of a whole smaller or larger, but knowing that we could have two different fractions naming the same amount of space. So the I can statement says I can represent a fraction with equal parts that are larger in size than the equal parts of an equivalent fraction. The Spark Your Learning says Thea is a landscaper. According to her design, 2/3 of the garden should contain red roses. She plants red roses in 4/6 of her new garden, not 2/3. Does Thea make a mistake? Show a way to solve the problem. So the way I'm going to solve this problem is by drawing two fraction strips and comparing the two fractions 2/3 and 4/6. So I'm going to draw my two fraction strips in the work mat, and those are just the long skinny rectangles. So I'm going to make sure that they are the same length as each other, And then the top one I'm going to do 4/6 because that's what she did with the red roses. And so I'm going to divide this into thirds first, and I'm going to divide the bottom one into thirds first as well. But the top one is supposed to be in sixths, so I'm going to divide the thirds into half to make 6 equal parts. And I could do that because 3 times 2 is 6. And so I know that I'll get sixths if I divide it in thirds first and then divide the thirds in half. So I am showing 4/6 because that's how many, that's the fraction of red roses that Thea planted. And so I'm going to color in 4 of the boxes, and those will represent the red roses. Okay, now I'm going to go to the next fraction strip and shade in 2/3 and see if the two fraction strips match or if one is greater than the other. So I'm going to fill in 2. And we see, okay, since our holes are the same, I can trust the visual model and see, oh my goodness, they line up perfectly. So 4/6 is the same as 2/3. I could do this another way where I just use one fraction strip and I divide it into thirds, and then on that same fraction strip I make sixths and see how many end up being shaded. So I'll come closer to the camera. So here's my thirds. If I want to make this into 6 equal parts, I'll just divide both of them in half, or all 3 of them in half. And now look how many parts I have. 1, 2, 3, 4, 5, 6. And the same amount is shaded, right? 1, 2, 3, 4 parts. So this is another way to show that 4/6 is the same as 2/3. So Thea does not make a mistake because even though she planted 4/6, that represents the same area or same amount as 2/3 of the garden does. Pretty cool. Okay, next page. Number 1, it says, at soccer practice, Coach Penny draws a diagram in which she divides the field into 8 equal-sized zones. The six zones closest to the goal are the scoring zones. So use Coach Penny's diagram to show the area she uses for the scoring zone. So here's the map, here's the goal, this is Coach Penny's diagram. So she divided it into 8 equal parts, and she says the 6 that are closest to the goal, that's the scoring zone. So I'm going to shade in those 6 pieces. Okay? Then it says, Coach Ruiz divides the same field into 4 equal-sized zones. Coach Ruiz's scoring zones are the 3 zones closest to the goal. Use Coach Ruiz's diagram to show the area he uses for the scoring zones. So I'm going to divide this rectangle into 4ths because that's what Coach Ruiz does. And I'm just going to do all vertical sections like that. Okay? And then it says that 3 zones closest to the goal are the scoring zones. So I'm going to color in those 3 like that. Then it says, part A says, what fraction can you write for the area of the field that Coach Penny uses for the scoring zones? Well, Coach Penny uses 6 out of the 8 zones. So that means our numerator is 6, our denominator is 8. Part B says, what fraction can you write to represent Coach Ruiz's zones? Coach Ruiz uses 3 of the 4 zones on his diagram. How do the fractions compare for the area of Coach Penny's and Coach Ruiz's scoring zones? Explain. Well, if you look at it, we have the same sized field and we have the same chunk missing, right? This area right here. So this shows that 6/8 and 3/4 covers the same area. So they are the same. Because they cover the same area. And so that's what you would write down. All right, the Turn and Talk says, which coach's soccer field diagram has a greater number of scoring zones? In which diagram are the scoring zones greater in size? So this is an interesting question because, yes, the 2 fractions are different, but they cover the same area. Now, if we're talking about scoring zones, which field diagram has a greater number of scoring zones, that would be Coach Penny's. But the size of the scoring zones are much smaller than Coach Ruiz, the diagram that Coach Ruiz drew. So there's more of them, but they're smaller. And why is that? Because the denominator is bigger. The denominator 8 is bigger than the denominator 4. And so we have to fit more pieces in the same area, the same space. So then in which diagram are the scoring zones greater in size? That would be Coach Ruiz, right? Because this diagram only has 4 scoring zones, but those scoring zones are bigger. So basically we could say 1 scoring zone of Coach Ruiz is equal to 2 scoring zones of Coach Penny's diagram. That space there is the same. All right, next page it says, 2 relay teams race across Lomas Park. The red team divides the distance equally among 6 runners. The blue team divides the distance equally among 3 runners. Show how both teams divide the race into equal distances. So the red team divides the distance equally among 6 runners. So that's our denominator. That's how many equal parts are in the whole. So I'm going to divide it into thirds first, and then divide the thirds into half to show 6 runners. So this right here shows the distance that 1 runner would race. Now for the blue team divides the distance equally among 3 runners. So the denominator on the blue team is 3. So this shows the distance that 1 runner would make. All right, part B says the first 4 runners for the red team and the first 2 runners for the blue team complete their parts of the race. Use the drawings to show the distances that the teams complete. So 4 of the runners completed their part of the race. So one runner went that far, then the next runner ran, then the third runner, and then the fourth runner went. Okay, so that's how far they've gotten. Now the red team, 2 of their runners completed their distances. So the first runner did all of this, and then the second runner ran all the way to here. Okay, making sense so far? So now it says locate and draw a point to show how much of the race each team completes. Complete the number line and show the fractions. So on the bottom of the number line, we're counting by thirds, and on the top of the number line, we're counting by sixths. So I'm going to say, okay, it marked 0 for me, so the next one will be 1, 2, 3, 4, and oops, 5. Okay, counting on top. Now this part I have to divide into thirds. I'm going to use the lines that are already there. I'm going to use this line and this line. So this will be 1/3, and this is 2/3, and then finally 3/3. Okay, so then how do the fractions of the race that each team completes compare? Which team completes more of the race? Well, the red team completed 4/6 of the race, and that's here. The blue team completed 2/3 of the race, and that is right there, the same spot. So, which team completes more of the race? They completed the same distance. So that's what you'll write here. They completed the same distance. Because 4/6 is equal to 2/3, as we proved in our drawing and on our number line. Okay, so now this is the part where I want you to pause and do the check understanding and the on your own, and then come back to the video when you're done to check your work. Okay, here's the check understanding. Number 1 says divide and shade the model to show an equivalent fraction. So we're starting with 4/8. Okay, so now I want to do a number that has a product 8. And that number is 4. So instead of dividing this into 8 equal parts, I'm going to divide it into 4 equal parts. So I'm going to go 1, 2. Okay, so I'm counting, I'll show you, it's kind of hard to hold it and draw at the same time. So I'm counting 1, 2, and then I'm drawing the line. Now why am I doing that? Why am I counting to 2 and drawing right on that line? Well, it's because 2, if I have 4 groups and 2 in each group, that gets me to 8. Oh my gosh, that's our major multiplication connection. So I'm going to continue 4 groups with 2 in each group. See how I did that? 2 into that group, 2 there, 2 there, 2. And so now I have 4 groups of 2. Okay, so then I will color in the same amount. So color in the first 2 and the next box. So how many boxes do I have all together? 1, 2, 3, 4 equal parts. And how many are shaded? 2. So that shows how 4/8 is equal to 2/4. Now the next one says draw a point to show 2/6. Then write the equivalent fraction. So again, like I did up here, with the number line, it has the sixths all marked out on the bottom. I'm going to count 2, and that's going to give me 1/3. Okay, because up top I'm counting by thirds. So 1, 2, and I'm doing this because 3 times 2 equals 6. So 1, 2, that's 1/3. And then 1, 2, 2/3. Like that. And then it says, draw a point to show 2/6, then write the equivalent fraction. So here I am at 2/6, and what fraction is there? 1/3. Okay, next page. Number 3, Mrs. Ash shades 1/2 of a rectangle. Will shades 3 of 6 sections of a same-sized rectangle. Will says that the 3 of 6 sections he shades are equivalent to 1/2, so both rectangles have the same area shaded. Is he correct? Explain why or why not. Okay, so now you might be thinking, yes, because 3 of 6, that is the same as 1/2, right? Because 3 is half of 6. And so the fraction 3/6 represents 1/2. But take a look at Will's picture. Did he draw equal parts? No way. Look, there's a huge part, a bunch of tiny parts, and then a medium-sized part. So the size of these parts are not equal, so we cannot use fractions to describe them. So no. Will the rectangles that he shaded in, or the parts that he shaded in his rectangle does not match up to the part Mrs. Ash shaded because he did not divide the rectangle into equal parts. So that's what you would have written down. All right, number 4, locate and draw a point on the number line for the fraction. Then write the equivalent fraction. So the bottom is in sixths, the top is in thirds. So again, I count 2 marks, write down 1/3. 2 marks, write down 2/3. 2 marks, write down 3/3. Like that. Find 6/6 on the number line, and it is the same as 3/3. And maybe we knew that even without using the number line, because if we have same number on top as we do on the bottom, if the numerator and denominator is the same, then that is one complete circle or one complete rectangle. So it's just equal to one whole. So then we would say, oh, well, if it's divided into thirds on top, then one whole would be 3/3. Number 5 says same thing for 4/8. Now, the bottom is divided into eighths, the top is divided into halves, and so I need to find the halfway mark. Now, what number can I multiply to 2 to get to 8? 4, right? 2 times 4 is 8, and so I'm going to count 4 spots. 1, 2, 3, 4, and that is my halfway mark. 0, half, 2, or 2/2. So then the same, what's the same as 4/8? 1/2. Because 8 is half of 4, or 4 is half of 8. Okay, number 6. Tim says that 2/8 of his water bottle is filled. John says that 1/4 of the bottle is filled. Are the two fractions equivalent? Draw a visual model to support your answer. So what I'm first going to do is divide this fraction strip into fourths. I'm going to divide both of them into fourths. Okay, and then this one I'm dividing into eighths. So I'm going to divide the fourths in half, and that will give me eighths. Okay, so see how they're equal to each other? So now 2/8 of Tim's water bottle, and then 1/4 of John's water bottle. And you can see that those represent the same amount. So yes, 2/8 and 1/4 are equivalent fractions. They represent the same amount. Alrighty, I hope that went well for you. If you need anything, let me know. But good luck on your homework assignment, and I will see you later. Love your guts. Bye.